let's finish up a little bit from last time, and then we'll go on to next time. Now we're having some analog world issues here. So let me tighten this up. We had talked last time. We'd sort of finished up some. Okay. Yes, the world is analog. Okay, there we go. We'd finished up with some remarks on various severity of different types of bugs. And we noted that bugs in new features are bad, but bugs in existing features tend to be much worse because they deliver negative value. When a client gets them, they're counting on a feature working for their workflow, and now it doesn't work. And they're often things that are missed because we end up testing predominantly the new things that are rolled out. And I notice there's a certain type of testing that does look for problems that break existing features rather than just new features. And that type of testing is called what type of testing? Regression testing. Regression testing will be looking for things that break old features, even though your main attention may be on the new features, the things that have changed. Okay. Quiz. You missed the solution, so you're lucky. Okay. Just in the nick of time. Okay. Fill it out. Sit away from someone who has their notebook open. Okay, good. So we talked about regression testing. Now, a really valuable fact, though, is if we have post-release users finding problems, it can really strengthen our testing process. Look, if we're doing the testing processes inside our own projects, we'll catch a certain number of things. But often it takes, another one. Often it takes external users, sit away from others in the back, and I'll collect this in about 10 to 15 minutes. It often takes other users to identify certain types of problems that we miss. Okay. And so when end users end up finding bugs, it can be really helpful for debugging our testing process. What is it we're allowing through? Is it that we're not testing with old enough machines? Is it the fact that people are running with these odd configurations that we didn't anticipate? Is it the fact that there's end user confusion about how to install the project? These are a lot of issues that in a test scenario can get missed, but end users can identify them. So end users are often some of your most valuable contributors in terms of understanding how you can improve your testing process. What are the holes in the process? So again, the issue here is not just fixing the bugs when you find a bug, and being responsive to the user and rolling out a new change. It's how can we prevent this from happening again, right? How can we stop this misunderstanding? How can we broaden our testing set of configurations so it will catch these things? And it can point you to whole areas where new problems might be found. Whether it's providing insights for regression testing or providing broad feedback on usability issues, report quality, etc., on the quality of the software, it can be very valuable. The risk here is if you have a system that's too broken, you're going to alienate customers. So all of this has led to a practice known as what sort of testing? Can anyone tell me? What's a common term for when you perform a certain amount of testing outside your organization or outside your project-involved people, and you do so with the conscious awareness on the part of the people testing it that this is a very new piece of software. It's not quite ready yet, but they want to try it out because it's cutting edge. They want to get a glimpse of what's coming. What is that called? Beta testing. Yeah. And often there's kind of an alpha test before that. Could someone get the lights on the left on the back there just so we can get a little bit less glare reduced? So with alpha testing and beta testing, successive stages of sort of level of refinement of the program, you often get some really good feedback on the system without risking as much alienating them, because they know they're consciously aware of the fact they're testing something which is not quite ready. And if you spin it the right way, they may actually feel it's to their advantage. Spin not in an inaccurate way, but if you reflect the fact that they're getting this, because they're getting this, they can develop against it. Because they're getting this, they'll be able to see what the features are. If you make it a free product for beta testing compared to one that will cost money for the final product, they will often find value in serving as beta testers. And often it's getting word of mouth going, for example, upstaging competition. I remember some products that gave a leg up on their competitors because they released their beta shortly before the competitors released their full product, and so people could see, well, yeah, the competition may have certain features in it, but that's coming along for this other product as well. It's in beta, and we'll be getting it eventually, so it may stop people from switching quite as much. Partners can build atop the beta often, and you can get public reviews of the project. So alpha and beta testing is sometimes looked on as kind of testing for free, but there's some shortcomings to it. Or there, maybe a better way to say is there's some limitations to it. Often the people who are testing it in beta testing are not representative users. Mind you, they may not be your testers, who are hardly representative at all, who are very skilled and using the product day in, day out, and so may not discover certain issues that end users do because they just so familiar to them. But beta testers are often cutting edge folks. They're folks that are power users, committed users of the project often, and as a result, the feedback they give you will not be representative of all people, all users. Sometimes they don't use the product that heavily. They sort of test it out, kick its tires, and leave it there. And if they don't give feedback, it's a bit ambiguous. It's because they didn't have problems, or they had lots of problems and they just got fed up with it. There is a risk you'll scare some away by early exposure, and often beta test users are doing this as a convenience to themselves, and they don't report bugs. So it can be hard to really get them to report, and when they are reporting, often it's not very high quality bug reports. Now, if your system has automatic bug reporting, which is strongly advised, I would love to see this in your projects. No matter who's using it, if there's a system problem, it will report that. Even if the users themselves aren't putting together bug reports, you may get reports of this assertion failure in this module at this line, or an out-of-memory condition at this location, which can be really helpful. So think about automated reporting being crossed with beta testing. Then you've got something really good going. But it's hard for developers to ascertain coverage without instrumentation of the code that might record where have people gone within this code base, and that can require some extra efforts. As always, I emphasize when a problem comes up, use it to sharpen your process, sharpen your testing skills so that you can figure out how to hone in on a problem more quickly and try to achieve better speed of what the issue is. Okay, those are some remarks from the end of last time. Any questions related to this testing material before I go on to a few other tips, and then we'll start talking about test case design? Any questions about this? Questions at a practical level about testing in your projects that have come up? I know each year I typically meet with a fair number of people from test teams. Often they're test leads or testers who are wondering, how do I test X, or how do I test Y? What do I do to effectively test this side of the product? And often it's not easy, but there are ways to probe at it. There are ways to get at it, sometimes with test hooks, sometimes with the right testing infrastructure around it, with the right test harnesses, etc. You can get some insights. Any questions about this? Okay, so with that, behind us, I want to go on to this next lecture here. Okay. Right. Okay. So we can divide up testing that occurs along many levels, and I hesitate to give a full taxonomy. But one of the more important ones is distinguishing testing that's sometimes called behavioral testing or black box testing. Basically, you're testing what the system does according to requirements and according to description, often through the UI, though not always. And you're trying to ask, to what degree does the design match the requirements? So you're using it from a user's perspective. And often it requires some domain knowledge. You have to understand what the program is supposed to do. So if you're using a program that archaeologists use for maintaining information on their archaeological sites, you need to know something about how archaeology works and common use cases and how people will be expecting to see certain results or summarized or what have you. But there are aspects of it that are quite technical. So security-based testing and performance testing. So security testing, what might you want to try there? If you want to work against your system to see if it's secure, what might you do?
Try to hack it?
Yeah, so let's make that more concrete. In what specific way?
SQL injection.
Yeah, SQL injection is a good one. So you go to edit boxes, and you know that the contents of those edit boxes, say it's a box for search, right? It's often probably pasted into an SQL statement, and then a search is done. So I go and I put in a thing in the search box for Vader, and it's pasted into an SQL statement. Look in a database for Vader. And what I do instead is I put some SQL. The hope is that it's naively stuck into an SQL statement, and by putting in comma or comment characters and putting in appropriate stars, maybe I can not only get it to return just certain information on products, but all information in the users tables, etc. So I can hack how it puts together the SQL queries internally to get access to extra information. So SQL injection is one. How about another one? Very common. Buffer overflows. What do you mean by buffer overflows? What if you're working in C? What bad things can happen? So you have an edit box, and if you're in a low-level language, C, C++, here you have a text box or edit box that I could type things in, and it's put into memory in some buffer that might be of some finite length. So what do? So this is the hypothesis, that maybe there's some finite length buffer behind this, maybe 256 characters. No one's going to enter a name of a book longer than that, or a destination to fly to longer than that. So what do? This is a null character in C. So what do you do with the buffer overflow? So yeah, you have a length that exceeds the maximum length here, and you hope that the later information here will overwrite other things in memory, and in fact be executed as code that I could write in areas that in fact are used for code of the program. And the hope will be by putting in characters in the later stages of this that actually are associated with assembly language or machine language instructions on the computer at hand, you might be able to trick it into executing some of that code, essentially inject a program into its memory that will do your bidding. All right? Okay, other aspects of security testing? Try breaking permissions mechanisms so that You can get access to other people's information on the site through the UI. See if it's easily possible to break in with username and different username and password information. It doesn't delay if you've used too many that time out or what have you. Maybe there's incomplete capturing of sort of options for resetting your password or what have you. Performance testing. This can be very specialized too, and it takes many types. Load testing, where you're testing many users against the system. Stress testing, where you're testing it under low memory conditions. You're testing its throughput, how many users how many user actions it can handle per unit time. Many types of performance testing. Okay, so behavioral testing. We'll talk a lot more about this, about some of the particular strategies. But then there's glass box testing, sometimes called white box testing, but it's structural testing. We're dealing here with how the system works. We know how the system works, and we're trying to see if it's working properly. So really here, instead of asking how does the design match the requirements, to what degree is the system matching up to its requirements, to what degree is the implementation working correctly per the design? And we'll use different tests there, but more to the point, we'll be testing the internals as we understand that it's built. As you might expect, behavioral testing might be have longer shelf life. Structural testing will depend on the data structures, the algorithms used, the structure of the program, which might evolve, even though the user, some aspects of user experience stay around. Okay, so black box tests are things you should be able to plan right now. Once the requirements stabilize, you should be able to think about them. And some of these black box tests go by special names. And in some areas of industry, these are very important distinctions, but one of them is acceptance tests. Anyone know what acceptance tests are? Like if you go to the pharmaceutical industry, huge amount of effort put into acceptance testing. Human lives are at stake very clearly if things go wrong, and so there's often really rigorous validation done before a system is deemed ready. And acceptance tests delineate a set of tests that have to run for the system to be considered ready. And there's actually a cottage industry of people who basically spend a lot of their time hired as consultants, often on very good salaries for large companies, to do acceptance tests on their products and to validate that and to give their stamp of approval so that customers have confidence that, or so the FDA has confidence in the US, the Food and Drug Administration, that this system works. Okay, so black box tests are type of tests that can be very fruitfully conducted by end users and less computer trained individuals. Often it's really valuable to have people who aren't very well computer trained. And you're focusing on common user tests, common things that are done. We're going to talk about a bunch of techniques for conducting these tests. And we'll highlight a number of them starting today. A number of them are listed here on the left-hand side. Broadly, there's systematic tests, and then there's less structured tests that probe other aspects of the system with semi-random or fully random sort of pounding based on sort of values that might be more likely to give problems or just trying different random values. And finally, there's exploratory testing, which is really important, where testers will actually probe the system interactively and take note of things that might seem odd or flaky or slow, etc. By contrast, for black box tests, glass box tests are taking advantage of the internal structure of the system. So they're helping to try to identify implementation errors that would be hard to probe with the UI. Thank you. Yep. Thanks very much. Hard to probe with the UI. Why would issues be hard to probe with the UI? Implementation issues. Why would they be difficult to figure out if this algorithm is working properly?
They may not be accessible yet?
Yeah, it's not accessible, and it's hard to fully. It's hard for me to put into words. But often, what's given back to the user in terms of feedback from a system is quite granular. It's quite coarse. Or it's quite coarse-grained. It's quite. It sort of summarizes in a very aggregate form a lot of specifics. And there might be things wrong down in the bowels somewhere. It won't be obvious from those summary results. Maybe, for example, you take out some money, you request withdrawal of money, or you request deposit of money to a certain account. By itself, it might say, okay, completed, but in order to really test that, you might want additional information. That information isn't always provided to the user on the UI. You might want to actually be able to see exactly what's been debited from where and credited to where, or what have you. So glass box testing will often involve the testers really understanding the system from their interactions with the developers. This is one of the reasons why having testers shadow or work alongside pair programming with testers can be really helpful. So they might want to focus on problematic modules, corner cases, which are kind of edge cases that aren't, they should be handled one way, but it's easy to be confused about which way they should be handled. Cases where there's a zero-length document or a document that's at the limit but not over it, or what have you. And often algorithm-specific testing that goes on. And we're going to be talking the next few lectures about things like path and call graph coverage that will provide principal ways of taking your system and breaking it up in a way that a test might systematically exploit. And you're going to try to define test cases that will cover a lot of portions of your system. So here, a lot of the attention is in the data structures, algorithms, and abstractions that are provided. And you may use test hooks or other standard methods, etc., to confirm the basic integrity of the data structures involved, to confirm the resources have been used as anticipated, that it's not using too much in the way of resources, etc. Okay, great. So, black box tests. What are some advantages? Well, you can list many, and you can do them once things are complete. Let's talk about these. Okay, so one principle for conducting certain types of black box tests are to identify regions of the space of all inputs that are handled differently, that are different, as we say, equivalence classes, that are associated with different types of responses. An example for this would be you're booking a ticket, and you can buy coach class tickets, or you can buy business or first class tickets, and then the user may further be able to request whether they want an aisle seat, a center seat, or a window seat, or what have you. And you want to make sure that at least each of these possible equivalence classes, that is business aisle, business window, coach aisle, window, coach aisle center, coach aisle window, each of those has been handled properly, because users can request them, and each of them within that category may be fairly interchangeable, but each of them requires somewhat different handling. So the idea here is that you'd select a representative from each of these equivalence classes, in this case 6, right? Kind of the Cartesian product of coach business on the one hand with aisle, window, and center. Although the center may not apply for the business class cabin. Okay, so the goal would be select at least one representative from each equivalence class and give it a try, and then to test some boundary cases, cases where it's not clear. An example would be if you have a plane where there's no center, for example. In that case, is the center option left out? Can you still select it? What happens if you do? And you want to consider here both valid and invalid cases. So the idea would be, instead of exhaustively trying to test this, that reserving each possible seat works or what have you, you at least put your efforts into having a breadth of cases that map into different classes. Another example would be for the square root function. Well, you tell me. Okay, so we have a function to perform a square root of a number. Maybe this is in Python, where you have complex numbers represented. What would be some cases you might want to check to make sure a square root function is operating correctly? What are certain equivalence classes of cases?
Square root of 0.
Okay, good. 0 is an interesting case.
-1.
It's a fixed point to the square root operator. Okay, that's good. Yeah, others? What's another fixed point of it?
Well, negative numbers. Not fixed point, but
Okay, how about a fixed point? Let's go for that one first. 1. Yeah, 0 and 1 are kind of interesting cases. Okay, some interesting numbers would be negatives. Yeah, we should be getting complex numbers back for negatives, or if we're dealing with a square root where it should signal an exception, for example, we might test that, right? So that's good. How about other common cases you might want to test for a square root in terms of equivalence classes? What would be a really easy set to test? Maybe a particularly common set. Perfect squares, yeah. Common set certainly maybe integers, right? Perfect squares would be a good one. It's really easy to test for smaller ones that it's operating correctly. And integers might be particularly common, so you want to try some of them. So these are good ones. And broadly, the point is we're not going to test it with all possible numbers. So let's be intelligent. If we're going to test it with a small to medium-sized set, let's be intelligent about at least exploring a bunch of cases where the logic of the algorithm might be different, the flow of the algorithm under the covers might be different, or where we expect different sorts of error conditions, different sorts of issues coming up. So perfect squares, there's 1s and 0, non-integers, there's values less than 0, etc. So coming up with equivalence classes can help you use your limited effort to greatest effect. Remember, it's all about risk management and all about opportunity costs. You can throw yourself at the square root operator for all sorts of random numbers, but that's going to take your time away from other sort of testing. And what's really notable, ladies and gentlemen, is that you can perform these tests at the level of the user interface. So if someone's asked to enter a number, and they have to be between 1 and 99. What was the age at which you first entered school or something like that. Okay, but then you might look at taking numbers within this category. Boundary values would be good ones, 1 and 99, and then a few in between. But then you also want to make sure that it works properly when you enter invalid inputs, something greater than 99, something that's 0, a negative number, an expression which isn't even a number, or an expression that evaluates the number, but it's not directly a number. These would be good things to put in. Maybe put in a number, put in digits in an alternative alphabet, right? Okay, first letter of a name, okay. Try different things someone might enter. And then try things which it should respond to in an invalid fashion. And for drawing a line, it has certain ranges, and you want to test outside those ranges and within it. So the point is to take your limited time and to put into things that are more likely to show problems, because otherwise you're wasting your time and you're missing potential cases that will bite a user. All right. A couple hints as to the equivalence classes. I recognize what I'm talking about are fairly toy examples, But they're common ones too. I mean, not square root perhaps, but things like edit boxes, entering numbers. I mean, these are common things. And having a few principles for them can be useful. More broadly, like if we want to try to find equivalence classes for a user form, how are we going to do that? Well, ask yourself, what things will basically lead to sort of logically similar results or error messages or logically comparable handling by the system, will lead to the same set of actions to be taken, lead to the same consequences. By the same token, if one of them is likely to find a bug, probably the others would elicit that same bug too. So we only need to test once. So, you know, you might group things according to whether they maintain the values of some underlying predicates. You know, cause similar internal operations, yield the same events, are on the same side of the correct value, etc. So the goal here is to try to, you know, okay, the system handles certain things in certain ways. Let's just be intelligent about getting at least a few from each class, and test broadly across those classes. Okay. So, you know, for your case, you're going to have forms. All of you are going to have apps or web pages with forms on them. Take advantage of that. Look for the equivalence classes for inputs, and consider them for invalid inputs. Remember, developers tend to be sympathetic. They tend to be sympathetic for the code. They're thinking, does it work on various valid inputs? You should be asking, does it work on invalid inputs? Not in the sense that does it magically know what to do for them, but does it yield the appropriate error messages or the appropriate refusal? Or does it just accept it and push the issue until a later error? You know, you might organize classifications in a table or outline or tree diagram for cases. Look for range of values or group membership of sort of common ones. Try to identify identical handling or outputs. So you're all going to have forms. You're all going to have things that have to be filled out by the user. You should be able to identify test cases that will exercise it. Those who are in the test team now, challenge your developers for this next round to do a paper prototype of what they're going to have. You know, what's on each form, if that's not already planned, and then use it to try to find some test cases that could test against it. That will be music to my ears next week if you can do something like that. These are the test cases we're testing against, and they should draw on some of these principles. Okay. Okay, so sometimes there's decision tables. You know, certain cases are handled in comparable ways. You know, they're broad categories. If a certain person has a number of claims, you know, and they fall within a certain age, how would the premium be adjusted? And should we send them a warning letter? Should we cancel their policy? And here, delineating these classes, you're going to want to test at least some from each of those classes. If you don't test one of these classes, it's just a bug waiting to happen. There could be a problem and you don't know it. You haven't even passed the red face test. If you exercise something from each of these classes and it seems to yield the correct result, does that mean the program's correct? No, but it really it can really help elevate the confidence, and it can help decrease the total doubt that it's working. You know, if you haven't tested one of these cases, it's hard to argue that you can stand in front of someone and say, we're confident that it works. Okay? So you might want to represent things as a decision tree. Now, one of the more important concepts I want to talk about, though, are these concepts of Latin squares and of orthogonal arrays. And depending on how the time goes, we may have to finish up with orthogonal arrays next time. So, who's seen Latin squares before? Anyone? Latin squares? They're a pretty popular construct. This is from Caius College in Cambridge, UK, and it depicts Latin square involving two axes here. What's special about this?
No one color has the same color on the same row or column.
That's exactly right. And by the same token, each color is on each row at least once, and it's on each column at least once. So,
Sudoku.
sorry?
Sudoku.
Yeah, it is somewhat related to that. Probably there's some isomorphism between them that I'd have to sit back and think about. But fundamentally, we are exercising a, if we have two fields, for example, we're exercising each of possible 10 values for each field at least once, and same thing for the other field. But we're not over-exercising. We're not testing all possible combinations of these. We're exercising each of the values at least once, but not in all possible combinations of them, right? Do you understand that principle? So if we have field 1, and it can take on 10 different values, and we have field 2 that can take on, so field 1, field 2, 10 different values. You're making sure that in your test cases, if you list out your test cases, call this field A, field B, better yet. Field A, field B will have, the value of A and the value of B, right? Maybe each of these could take on, to simplify it, maybe each of them can take on 3 values, right? We want to make sure that field A has in some test case tried value 1, some test case tried a value 2, and some test case tried a value 3. And the same thing with B. We want to guarantee that somewhere it's tried 1, 2, and 3. But we're not going to consider all possible combinations of these, which would be 9 possible combinations. In this case, the 9 are modest, but as the number of possibilities goes up from 3 to 10, for example, each or 100, it's going to become prohibitive to try all possible combinations. But we could enumerate cases that would try each of the 3. Give me an example where we could try each of these 3 sort of in isolation. Okay, so we could have 1, 1, right? We're trying some test case with 1, 2, and 3. So here we've exercised all 3 of B, all 3 of A. But we haven't done so in a way that's been exhaustive. We haven't tested 1 and 3. We haven't tested 2 and 3, etc. So with Latin squares, we're trying to make sure that at least we cover all possible values of B and all possible values of A. And if they're the same number, it's more straightforward of each. But if we have multiples of each, it can be more complex. And if we have more possibilities. So Latin squares guarantees each value is tried at least once. I'll leave you with this, and then we'll continue on it next time. Orthogonal arrays. So orthogonal arrays basically provide something that's one level up higher in terms of constraints than Latin squares. Latin squares are going to guarantee that each value of each possibility is handled at least once. And that's good. After all, if we didn't handle each of the 3, how could we be sure field A is working properly? But with an orthogonal array, what we're guaranteeing is that each combination occurs at least once, each pair of possible values. So not that we have all possible pairs if we have field A, field B, field C, field D, but at least any pair of any 2 columns will occur at least once. We'll see how orthogonal arrays work, but they specifically are dealing with this case where we have more than 2 criteria. And yet we're going to be examining it on a pairwise basis. Okay? And they really enormously reduce the number of cases we have to consider down to a very manageable number. So we'll talk about this next time and go through how orthogonal arrays can greatly reduce the number of possibilities down while still allowing you to explore pairwise compatibility. Okay? So that's all for today. and I'll look forward to seeing on, to receiving your ID deliverables and to seeing you on Tuesday for your presentations.